In early 2012, ITUR embarked on a program to develop IMT 2020, setting the stage for the 5G research activities that have since emerged across the world. The European Commission 5G research activities began in November 2012 with the co-funding of METIS. Mobile and Wireless Communications Enablers for the 2020 Information Society. The industry buzz on 5G increased dramatically in 2014. Attention was becoming more focused on establishing the operator's view of the enablers for a connected society in the 2020 and beyond timeframe. In 2015, the ITUR finalized its vision of the 5G mobile broadband connected society. Moving forward, the 3GPP starts working on a more detailed set of standards for 5G. Their initial focus is on setting requirements, followed by formal study items to baseline the architecture and radio technologies. This will lead to work items between 2017 and 2019 to define the complete 5G specification, resulting in the first release being issued as part of 3GPP Release 15. In March 2017, industry agreed on 5G NR acceleration. The accelerated schedule helped eliminate a perceived threat from market fragmentation. In December 2017, 3GPP approved the set of specifications which define the non-standalone NSA architecture option, which leverages the LTE and NR interfaces, as well as the existing LTE core network (EPC). Standalone NR operation is part of the final 3GPP Release 15 specification completed in June 2018. Full IMT 2020 compliance will be part of 3GPP Release 16, to be finalized in 2019. After initial delivery in 2017 of non-standalone NSA NR specifications for 5G, much effort focused in 2018 on timely completion of 3GPP Release 15, the first full set of 5G standards, and on work to pass the first milestones for the 3GPP submission towards IMT 2020. Release 15 focus is enhanced mobile broadband, and therefore all features are geared towards enabling the 5G system, Phase 1. Massive MTC and Internet of Things, IoT. Vehicle-to-Everything Communications, V2X, Phase 2. Mission Critical, MC. Interworking with legacy systems. LAN and unlicensed spectrum use. Slicing, logical end-to-end networks. API exposure, third-party access to 5G services. Service-based architecture. Further LTE improvements. Mobile communication system for railways. The major characteristics of 5G, Release 15 Phase 1 that enable eMBB, from 10 GB per second to 20 GB per second, include ultra-wide bandwidth, up to 100 MHz in less than 6 GHz, up to 400 MHz in greater than 6 GHz. Set of different numerologies for optimal operation in different frequency ranges. Native forward compatibility mechanisms. New channel coding. Native support for low latency and ultra reliability. Flexible and modular RAN architecture, split frontal, split control and user plane. Native end-to-end support for network slicing. As the Release 15 work has matured and drawn close to completion, the group's focus is now shifting onto the first stage of Release 16, often referred to informally as 5G Release 15 Phase 2 feet. As the Release 15 work has matured and drawn close to completion, the group's focus is now shifting onto the first stage of Release 16, often referred to 5G Release 15 Phase 2. Ending July 3, 2020, Release 16 was completed with both the Stage 3 freeze and the ASN1 and Open API specification freeze being approved. The major focus in Release 16 is to enabling ultra-reliable low latency for mission-critical applications. The 5G system Phase 2. Enhancement of ultra-reliable, UR, low-latency communications, URLLC. Cellular IoT support and evolution. Advanced V2X support. 5G location and positioning services. UE radio capability signaling optimization. Enablers for network automation architecture for 5G. Wireless and wireline convergence enhancement. Mission critical, public warning, railways and maritime. Streaming and TV. User identities, authentication, multi-device, network, slicing. From a business angle, Release 16 enables applications for new vertical industries and deployment scenarios. Integrated Access and Backhaul, IAB. NR in unlicensed spectrum. Features for Industrial Internet of Things, IIoT, and ultra-reliable low-latency communication, URLLC. Intelligent Transportation Systems, ITS, and Vehicle-to-Anything, V2X, communications, positioning. The building blocks of 5G that enable URLLC include low latency, time synchronization, resource management, reliability. In 2020 Release 17. Study items for Release 17 are 5G up to 71 GHz and to explore new and more efficient waveforms for the 52.6 to 71 GHz band. 5G NB-IoT and EMTC. The objective is to develop cost-effective devices with capabilities that lie between the full-featured NR and low-power wireless access. 5G XR. The objective of this is to evaluate and adopt improvements that make 5G even better suited for augmented reality, virtual reality, and mixed reality. 5G non-terrestrial network, NTN, support for NR, NB-IoT and EMTC. A typical NTN is the satellite network. The objective is to address verticals such as mining and agriculture, which mostly lie in remote areas, as well as to enable global asset management, transcending continents and oceans.